Physics tells us that whenever material bodies interact between each other, they undertake a modification, regardless they are living or inanimate bodies. The interactions between human beings and the environment make no exception. Ever since humans have walked the earth, they have been increasingly changing it. In the contemporary era, the ever-increasing human intervention in the Earth system is causing a major alteration of some planetary biogeochemical cycles that are essential for almost all living organisms. This is a further major tangible effect of human energy use on the natural world. A biogeochemical cycle refers to the turnover of a selected material stream, more specifically an atom, which cyclically evolves to different chemical substances. Usually, this evolution goes through both biotic and abiotic compartments of Earth that encompass the hydrosphere, lithosphere, and atmosphere. The most important of these cycles, all crucial for the existence of life for complex organisms, are the cycle of hydrogen or water, the carbon cycle, the nitrogen cycle, the phosphorus cycle, and the sulfur cycle. Each cycle is named according to the specific chemical element that evolves through it. For brevity, we consider now only the first 4 cycles. Water was and is essential for the existence and evolution of life. Oceans and seas cover around 71% of the total surface of the Earth and play a crucial role in the establishment of the radiative balance with the Sun. Water is also a driver in the photosynthetic process of autotrophic organisms as a hydrogen donor. The water cycle is probably the first one that humans have experienced directly. Water passes through different solid, gaseous, and liquid regions of the planet with complex steps of evaporation, condensation, precipitation, runoff, infiltration, and groundwater flow. The mass of water on Earth remains fairly constant over time. However, what changes is its partitioning into the major reservoirs of oceans, saline lakes, saline groundwaters, and freshwaters. This allocation is variable depending on a wide range of climate variables. Freshwater is mostly contained in glaciers and ice caps. 1/3 is accumulated in groundwater, while the remainder is in basins of surface waters and other sinks. Notably, the fraction contained in the atmosphere as vapor is a very small quantity, that is around 0.22% of total surface waters and other sinks. Water has always been a fundamental resource for both biological requirements and civilization needs of humankind. For this reason, the capability to access water is a primary responsibility and a concern as well. Indeed, today water withdrawal is much relevant for several human services like public supply, irrigation, livestock, and thermoelectric power. Notably, the daily human utilization of water has exceeded 1,500 billion liters in last years. Let's now discuss about the carbon cycle. Especially in the last decades, it has been much understudied because of the global warming potential of carbon dioxide from anthropogenic activities. The carbon in biosphere moves with complex mechanisms between sea, land, and atmosphere. The main form of carbon in the atmosphere is carbon dioxide, with an overall amount over than 800 petagrams of carbon. The terrestrial biosphere contains carbon in the form of organic molecules of the biomass of all living organisms, dead organic matter in soils and in permafrost soils. Carbon dioxide is also dissolved in ocean water, where it's found as inorganic carbon, that is carbonic acid, bicarbonate, and carbonate ions. The processes of photosynthesis and respiration of all forms of life cause a continuous exchange of carbon between the atmosphere and biomass. The result is a net yearly accumulation of around 3 petagrams of carbon in plants. Human activities interfere with these delicate natural mechanisms by artificially altering the natural amount of carbon dioxide. On the one hand, carbon dioxide concentration is increased as a result of combustion processes. On the other hand, the massive deforestation reduces the overall amount that is absorbed by vegetation. Currently, the concentration of carbon dioxide in the atmosphere has reached a level slightly higher than 400 parts per million, corresponding to a mass exceeding 800 petagrams of carbon. This quantity is comparable with the carbon stock in living vegetation. A net increased absorption of carbon dioxide by oceans has also occurred since the pre-industrial age. That means ocean acidification. Ocean acidification has been referred as the global warming's evil twin due to its fundamental importance in sustaining various ecosystems, especially marine living organisms. Water and carbon cycles are much studied and widely discussed because they have evident nexus with energy production and uses. There are, however, other biogeochemical cycles that are worth to be discussed because they can explain other essential linkages between natural and anthropogenic energetics. The nexus with food production is obviously one much relevant to understand.